In this question we're asked to find the midpoint of the line AB, and it said find the coordinates of M, so where M is the midpoint. So first things first, let's join A to B, and let's try and understand something, that if we have a triangle here, a right angled triangle, then if we want to get to M, then we really must go halfway along here and then halfway up here. So if we know that A is 2, 3 and B is 6, 8, a good way of doing that, that works every time, is to do the average of the x ordinate. So that's 2 plus 6 halved, and then to do the average of the y ordinate, which is 3 plus 8 halved. Now let's see if that works. Well, 2 plus 6 is 8 divided by 2 is 4, and 3 plus 8 is 11 divided by 2, we'll just call it 11 over 2. So I'm saying that will be the midpoint. But let's see in this diagram if this works. So this was 2, 3, this was 6, 8. So if I was to go along on the x first, halfway, the distance between starting at 2 and ending at 6 is 4. And then for the y, if I'm starting on 3 and then going up to 8, that's the distance of 5. So if you think about it, if I started on 2 and I'm going halfway of 4, I'm adding 2. So 4 was correct. And if I look at the y's and I'm starting on 3 and then I'm going up halfway, which is 5 over 2, then what's my y coordinate going to be? Well, it's going to be 3 plus 5 over 2, which is 6 over 2 plus 5 over 2, which is indeed 11 over 2. So it doesn't matter if you give your answer as a decimal, that's absolutely fine. But I just want you to understand that you're really finding the averages of the x ordinate and the y ordinate. Okay, so that's that question done. For this question it says there's a table showing the average temperature on each of the 7 days and the number of units of gas used to heat a house on these days. So it gives you the graph here, and you have to fill in the points, I would say. So it says complete the scatter graph to show the information in the table. The first 5 points have been plotted for you, so we haven't got to worry about these ones. So we've got to worry about these ones here. So average temperature is along here and units of gas is up here. So we want to plot 12 along, 6 up. So 12 along and then 6 up. There's 1 point there. And then 13 along, 2 up. So 13 is here. So 13 along and 2 up would be here. So be very careful that you can read the scale. So that's definitely one thing they're testing here. Then it says, describe the relationship between the average temperature and the number of units of gas used. Well, first of all, what you need to do in this situation is to draw a line which shows the trend. Now, you can see generally the trend here is going like so. But what you want to do is, first you want to get a line drawn. So we'll do that first. And what we want to do with the line is, we want to make sure that the line shows the trend as best as possible. So you don't want it necessarily like this, although that is a downward trend. You want to make sure that it goes through as many points as possible. Now, there's no perfect science to this, but if you had a point, say, up here, you wouldn't want to necessarily move your line to get closer to it, because you would really treat this one as an outlier and ignore it. So you want to look at the cluster of points that are showing the trend. So that's where you'd put your line. So if I just go back here and show you where I ended up, that would be where my line of best fit would be. Now, obviously you don't have to go off the scale here. but that's just how my line has looked. So you just have your line showing your line of best fit, and then you've got to describe the relationship between the average temperature and the number of units of gas used. Well, there's a number of ways that you can do this. Firstly, you can describe it in words, and you can say, as the average temperature increases, the units of gas used decreases. Or you can say there is a negative correlation. And in this case I would say strong. In my experience as an examiner, I would say that both, either or, would get the mark. You can put both, that's just as well. So you can say there's a strong negative correlation showing that as the average temperature increases, the units of gas used decreases. And use common sense there. The warmer it would be outside, then basically the amount of gas you would use to heat your home would be less. So I think there's another part to this question. So part C said that estimate the average temperature on a day when 12 units of gas are used. Well, you read along from 12, draw a dotted line. Even my strongest students sometimes forget to do that and lose a mark. You must show how you've used your line of best fit, and then read downwards. And be careful of the scale. This is 5 here, this is 6. So we're looking at around 5.5. So I'd say for part C, I'd go for 5.5 degrees centigrade. That's just what I'd put. My sense tells me that the mark scheme would probably allow somewhere between 5 to 7 degrees Celsius. So that's what I'd put down, and I'd be confident that was correct. So let's have a look at the next question. So for this question, you're asked to work out the value of an expression when x is 0.7. So if you just substitute 0.7 in, then be aware that if you want to put this on your calculator, there's numerous things that you can actually do. The first thing is you can type in exactly what I'm writing here, and then press ANS or equals and write down what that part would be. So that would give you 2.89, and then you can do the denominator part, which is 1.4, and then you can type that back into the calculator, 2.89 divided by 1.4, and then write down all the figures on your calculator display. And my online calculator says 2.064285714. So that's one way of doing it. Another way is to put it all in one go. Now, what you'd have to then do is write bracket 0.7 plus 1 to the power 2, close bracket. So what that really does is just do this part separate, because these brackets here are telling you to make that separate. Then divide by, and then open up another bracket, 2 times 0.7, and then press ANS or equals. And that should give you the same answer. sometimes students rush into these and get the answer completely wrong. It doesn't hurt to check a little bit. If you wanted to check the answer out by hand, you could say that 0.7 is 7/10 plus 1, which is 10/10 squared. Well, that's just 17/10 squared, which is 289 hundredths, which gives you the 2.89. So don't just put things into the calculator and don't pay attention to the answers. Just try and think, do they make sense? So that's that question. Let's go on to the next. So, diagram of a circle. It says the diameter of a circle is 9 centimeters. Work out the circumference of this circle. Give your answer correct to 3 significant figures. Well, basically, when you have a circle, the circumference is supposed to wrap around it once, twice, 3 times, and a bit. So that basic ratio is called pi. So if you times pi by the diameter, you will always get the circumference. So that's basically telling you that if you say pi is roughly 3.14, it's telling you that a diameter will wrap around the outside 3.14 times or thereabouts. So it says here, work out the circumference of this circle, give your answer correct to 3 significant figures. So the circumference of a circle is pi multiplied by the diameter. In this case, it's pi multiplied by 9. You would put that in your calculator, and then you would write, the display on your calculator would be minus 28.274333882, and then you want it to 3 significant figures. So let's have a look at that. If you have a number here and you want it to 3 significant figures, this is the first significant figure, i.e. to the nearest 10. So if it was to 1 significant figure, the answer would be 30. This is the second significant figure, i.e. to the nearest unit. So to the nearest unit, the answer would be just 28. But if you want it to 3 significant figures, then you really want it to the nearest 10th. That's all it's saying. So you would just give your answer as 28 well, think about it. You know how to round to decimal places. So you look at the number after it. If it's a 5, 6, 7, 8 or 9, then it pushes this number up, and it does in this case. So you would say 28.3 centimetres squares, and I would just write in 3SF at the end. So that's that question there. Let's have a look at the next one. Describe the single transformation that maps triangle A onto triangle B. Well, in this instance, it's going to be a translation. Now, what I mean by that is, if you choose a point here and see how that point gets to the corresponding point here, what happens? Well, I'm going along 1, 2, 3, 4, 5. And then I'm going down 1, 2, 3. Now that's what you'd put down as your answer. You'd say triangle A is translated by the vector 5 minus 3. You wouldn't write 5 minus 3 because all that is a coordinate, 5 along, 3 down. And that would have no meaning in this situation. So this would be the correct answer here. So I think on the answer line I would just say this, I would say translation by, let's get rid of that, translation by 5 minus 3. And any mathematician would know that would be a vector translation. That's the neatest way of doing it. I know some students say this, they say along 5, down 3. I think you probably only get 1 mark for that. What they're really trying to look for is these keywords and this kind of notation being used. So question 6. There's a lot of information here. So these are quite difficult, and I think a lot of students have difficulty, as do I, with when there's loads of words in a context and you have to try and pick out the information and get on with the maths. I find these questions by far the most difficult, actually. So let's have a look and see if we've got any information here that we can look at. Well, for this question, I think I would start off by looking at what time she left her friend's house. So she left at 9 a.m. All of this here is just telling you how many miles it is from each of the parts, from the friend's house to the motorway, how much on the motorway, and then motorway to home. But we want to look at the time she got home. So I'd say it took 20 minutes to drive from her friend's house to the motorway. So we can say there's 20 minutes to take into account there, to add on. Then we can say drives at an average speed of 60 miles per hour on the motorway. Well, if there was 240 miles on the motorway, if you can work out how many 60s go into 240, well, you know that 6 fours is 24. And even on your calculator, you could do 240 divided by 60, and that would give you the answer. But let's just say 6 fours are 24. So we'd have 60 lots of 4 would be 240. So we've got 4 hours here. And if you want to convert it to minutes, it's up to you, but I'm just going to write 4 hours here for now. So we've done this part here, and then it takes 25 minutes to drive from the motorway to our home. So there we go, another 25 minutes. And then there's another bit of information. She stops for a 30-minute rest on her drive home, so we have to dial that in as well. So here's how I would approach this. I would simply say 9 a.m. I would do the 4 hours first, so that would get you to 1 p.m. Then I would do the 20 and the 30 is 50, so that takes us to 1:50 p.m. and then I'll try and add 25 minutes to that. So if you add 10 minutes rather, you'd get to 2 and you'd have 2:15 p.m. would be the time that you got home. So I think that shows all the working out there. You've started by breaking the problem down. You've done every little bit it asks, so 20 minutes from the drive to her friend's house to the motorway. The average speed you've done well enough there, and you've dialed in all the other bits of information that are needed. So my answer would be 2:15 p.m. You might have a different way of doing it. Just set your work out and try and show the examiner what you're doing, and then you should be able to get all the marks. Well, in this question here, we have quality of written communication. So we've really got to show all our workings here. It says PRS and TWY are parallel straight lines. That's shown by these signs here. And we've got QRWZ is a straight line. Well, the straight line that cuts through two parallel lines is called a transversal line. That's just for your information. And it says, work out the value of x, give reasons for your answer. Well, first of all, we can see here we have alternate angles. And I remember that because I go alternate. It's got 3 syllables and there's 3 strokes to the angle. So 1, 2, 3. That's how I remember it. You used to be able to call it Z angles, but you don't get marks for that anymore. They stopped that about 4 or 5 years ago. So what I would be saying here to start with is, I would be saying that this would be x degrees on my diagram, and so I would say angle RWY equals angle PRW, because they are alternate angles, and so I use this little angle sign with an apostrophe S for angles. that's the first thing that I would say. So I'd say angle RWY is angle PRW, which is equal to x degrees, because they are alternate angles. That's the first thing to do. And then the second thing to do is just to notice that angles on a straight line, so angles on a straight line add to 180 degrees. So you can therefore say that x equals 180 minus 126, which you can do on your calculator. You have the luxury of doing that. So you've got 54 degrees. So x is 54 degrees. And that should be plenty of information. Don't forget, coming back to this transversal, if the transversal was here, then although this is not a Z here, it's still the same rule applies. So this would be alternate angles as well. And you can also have the situation where you go 1, 2, 3, and then these would be the same. Okay, so look out for that Z kind of shape, whether it's back to front or not. It doesn't really matter. But just don't say Z angles. You don't get the marks anymore. So let's have a look at this question now. Again, there's quite a lot of information here, but it's basically saying what is the probability that this customer went to the shop 5 or more times. So you have to look at the table of information and you have to work out that 100 customers were looked at, and you have to work out the probability that this customer went to the shop 5 or more times. So we're basically looking at all of this information here. So what I would simply do is I would add up 13, 11 and 5, and that would be 24, and 5, that's 29. And then I know that all of these must add up to 100, because in here it says 100 customers were asked. So the probability that this customer went to the shop 5 or more times would be all of those numbers inclusive. So that would be 29 out of 100. Now this second part is a little bit more tricky. It's all about relative frequency, and for 2 marks you've got to work out, based on the fact that there's now 1,500 customers last month at the shop, work out an estimate for the number of customers. So when you're using probability and estimation, you're looking at relative frequency. So you're saying to yourself, what would it have been in the original model? Well, if you had 2 times at the shop, then it would have been 13 out of the 100. But you want to do it for 1,500 customers. So what do you think you'd have to do with this fraction, 13 hundredths? Well, this would basically be your multiplier. So you would say, based on the model of 100 customers, 13 out of the 100 went there exactly 2 times. So you would just multiply that by 1,500, and that would be the relative answer for 1,500 customers. So you would just do that on your calculator. I won't, because I'll just say 13 times 15, so that will be 150 and 45. So I would end up with 195. If on your calculator, all you'd have to do is 13 times 1,500 and then divide it by 100. You wouldn't need any brackets in there. So hopefully you'd get 195 customers. Well, now there's a situation where the owner of a different shop is carrying out a survey on the ages of his customers. He records the ages of the first 10, which already strikes me as a bit strange, in his shop after 9 AM, and that's also a little bit strange to me. Why is this not suitable? Well, if you want to know about the ages of your customers, then firstly, 10 is not enough. Does not represent the population very well. and I'd say in terms of age. So think about it. You want to do a survey about ages of customers and you just ask 10 people, you could be having hundreds of customers through the door. And the other thing is they're not all going to come through the door at 9 a.m. in the morning. You might get maybe, for example, the older ones coming in because they might get up earlier and get their shopping done. And then you might get certain people who have to go to work who might be slightly younger and they might not get to the shop before 6 o'clock or 5 o'clock in the evening. So really, you also need to say something about the time. And I would say customers at this time. So I'd say customers at 9 a.m. won't necessarily represent the ages of customers. Now you don't have to go into such a lot of detail there, just say 10's not really enough, it doesn't represent the sample. I think you can use words like representative, and also the time may not really represent the ages of the customers at all, because like I said before, people will come in at different times, and if you just do it at 9 a.m. you might just get a certain demographic, and that's another word as well, demographic. And that can show you about the split down of the ages. So just use your common sense really, just think of a shop and think about its customers. Okay, so next one. The diagram shows a trapezium and it's given all the information here. It says the perimeter of the trapezium is 38 centimetres, work out the length of AD. Well, it says AD is X centimetres, BC is the same length as AD. Okay, that's useful. It says that AB is twice the length of AD, so AB is twice the length of AD, so that's got to be 2x. And it says DC is 4 centimetres longer than AB, so that's going to be 2x plus 4 or 4 plus 2x, either way. It says the perimeter of the trapezium is 38 centimetres, work out the length of AD. Well, the perimeter is all the way around the shape, so imagine walking all the way around it. So you'd have x plus 2x plus another x plus 2x plus 4, and that would have to be equal to 38. So sum your terms together, simplify, so we'd get 2 4 6x plus 4 equals 38, and then you're basically setting up a balance equation here. So take away 4 from both sides, and that would give you 6x equals 34, and then divide both sides by 6, and you'd have x is 34 over 6, which would be fine to leave, or you could just write 17 over 3. I don't know if there's much to be gained in using your calculator here. You could do 17 divided by 3, which I'll do by hand here. 5 3s are 15, with 2 left over, and that will be 6. So you get 5.6 recurring, but I don't think that's necessarily a good thing to do. Just leave it as 17 over 3 centimetres. Now with this question we've got some simplification to do. So in the first question we've got p cubed all squared, so we've got p cubed times p cubed. You don't need the brackets, but I'm just trying to show you what that looks like. And then if you're still not sure, that's p times p times p times p times p times p, and they're all to the power 1. So you've really got p to the power 6 by the rules of indices, which you would have here. You just add the powers. So here you've got p to the 6. With this one you've got t to the 8. So 1, 2, 3, 4, 5, 6, 7, 8 and t cubed. I'm using the dot for times here. So that's one way of looking at it. If you know the rules, then you know the answer's going to be, if I write this out here, you know the rules of indices, then you'll know the answer would be t to the 5. But if you don't know that, then just cancel these through, because every time you have a t divided by a t, that's the same as writing 1. So you'd be ended up with 1, 2, 3, 4, 5 t's multiplying each other. So you wouldn't say 5t, because that means 5 times t. You've got t times t times t times t times t, which is t to the power 5. For the last part, well, one of the last bits, you've got 2 cubed times 2 to the power of something is 2 to the power of 9. Well, don't worry too much about this. Just try and think to yourself, what would n have to be for the rules of indices to give the answer of 2 to the 9? Well, this would have to be 6 here, wouldn't it? Okay, I don't think the question's necessarily asking you to solve it for n, because if you divided both sides by 2 to the 3 in this case, you would have 2 to the n is 2 to the 9 divided by 2 to the 3, which is 2 to the 6. So you could see that to make this balance, n would have to be 6 to make it be the same as this one here. So if you looked at a balance equation here, then you'd have to see that the value of n would have to correspond with 6 here. So I would just say n is 6, and there's a number of ways you can show that. For the next question, you've got to work out the value of x from this. So this is just trying to test to see whether you know the difference between this and this. Well, let's have a look at this in some kind of diagram. If I make this x cubed, there we go. So that's a cube, and it has length x all the way. Then its volume inside is going to be x cubed. And all this is saying is, I want 2 of them. So imagine drawing that diagram twice. However, this situation is saying you've got a cube, but in this case, its length is 2x in all directions. So if you carry this one through here, not a brilliant diagram, but it will do, then you can see that this one here would fit into this one quite a few times. In fact, if I can draw this one out here, you can probably see that I'm going to be able to get 1, 2, 3, 4, 5, 6, 7, 8 of these in place of this one. So if I put 8 of these into this one, then that would fill the entire volume. So just be careful. So back to the question, 2x cubed is 128. This means 2 lots of x cubed equals 128. So x cubed would be, well, divide both sides by 2, 64, and then on your calculator you can do 64 to the power 1/3 with brackets, or you can use your power button on your calculator, and that'll be different for all of you, but you should be able to see in your head that 4 times 4 times 4 is 64. So the cube root is going to be 4. So x is going to be 4 in this situation. Question 11. It's a plan of a driveway, and you've got to cover the driveway with gravel. the gravel will be 6 centimetres deep. Gravel is sold in bags. There are 0.4 metre cubes of gravel in each bag, and each bag costs £38. Martin gets a discount of 30% off the cost of the gravel. Work out the total amount of money Martin pays for the gravel. So, it gives you the driveway, which is good because you know that's going to be 4 by 11. So you know the area of the base is going to be 4 by 11, which is 44 metres squares. Then you also know it's got to be 6 centimetres deep. Now here's the first thing that's going to catch out students. You really should think about making the conversions the same. And what I mean by that is there's 100 centimetres in 1 metre. So 6 centimetres, well, what's that going to be? Well, it's going to be 0.06 metres. So if you want to work out the volume of gravel needed, this is what this is really testing here, then you need to be able to do not just 4 by 11 in terms of metres, but you need to times it by the height in metres. Okay, and that answer there would be how many metre cubes you wanted. The alternative is that you could change everything into centimetres and then do the volume would be 1,100 times 400 times 6, and that would be centimetre cubes. But I'd rather have it in metre cubes because I know that I've got 0.4 metre cubes of gravel and what it costs in each bag. Okay, so I'm going to do 4 times 11 times 0.06, and that gives me 2.64 metre cubes. Now here's the thing now, this is where the question gets a little bit tricky. If then you've got 2.64 metre cubes for the driveway, you know that it's 0.4 metre cubes of gravel in each bag. So you've got to now divide 2.64 by 0.4, which I'm sure you can do on your calculator. I will just show you a way of doing it without. Times top and bottom by 10. And then times top and bottom by 10 again. Halve both sides. And halve both sides again. And then you end up with 6.6, which is what I hope you got before. So we know we've got 6.6 bags worth. So he's going to have to either get 6, which is not going to be enough. He could argue with the salesperson, I want 0.6 of a bag, and the salesperson would probably tell him where to go. So I would say 6.6 would be not a good thing to write down. You would want 7 bags. So there's our 7 bags. Now, Martin gets a discount of 30% off the cost of the gravel. So the next thing you have to do on the calculator is to say 7 bags at £38, which I'm sure you can work out. So that would be 210 plus 56. So that would be £266, but then you get the 30% discount. Now there's a good way of doing 30% off, because if you think 100% is all of it, if you want 30% off, then only 70% will remain. And if you know what 70% is the decimal, which is 0.7, you can just times that by 266. So I'm just going to see what that is. I don't know what that is in my head. I should. But it's the calculator paper anyway. So times it by 0.7. And that would be £186.20. An alternative way is that once you've worked out how much you've paid, say £266, You could use the calculator to work out the percentages, but you could use the calculator to work out each step if you want. So if you want 10%, then that's going to be £26.60, and then 30%, you could just times that by 3 on your calculator. So I'll do that here by hand. So 6, 12, 18, 19, 246, that's £79.80, and then you could just use your calculator to take £79.80 off, and you'd end up with £186.20 again. So I think having a calculator doesn't mean you don't have to think. It means that there's many ways of doing the question. You've just got to set your work out and somehow show the examiner you know what you're doing. So for this question, we've got an arithmetic sequence. An arithmetic sequence just means that you're going up or down by the same number using plus or minus. So I'll give you some examples. You could start with 3 and you can go up by 2. So you could go by 2 again, and so on. That's a nice arithmetic sequence. You could start with 5 and go back by 7. So you could go to -2, -9, -16, -23, and so on. There's another kind of sequence you can have, and that's called a geometric sequence. And that's one where you would start with, say, 4, and you might multiply by 3 each time. So 4 times 3 is 12, times 3 is 36, times 3 is 108, times 3 is 324, and so on. But that's not tested on GCSE. So arithmetic, just think of arithmetic, simple arithmetic, adding or taking. So while I rub this out, we can look at the question with fresh eyes and see, well, in terms of n, an expression for the nth term of the sequence. Well, the first thing to think about with sequences is, what does it go up in? Well, it goes up in 5s. So if you write the 5 times table out, and put your sequence underneath, all you've got to do is compare them. So how is this similar to this? Well, this sequence here seems to be the 5 times table. Now the 5 times table is written as 5n, and we've got to somehow take 1 from the 5 times table. So here's the 5 times table there, and how do we get to here? Well, we have to take away 1, take away 1, take away 1, and so on. So this must be something to do with the 5 times table because it goes up in 5s, but we've just got to adjust it by 1 each time. So I would say in terms of n, an expression for the nth term of this sequence would be 5n minus 1. So I'll do one more. Let's do 3, 7, so it's going up in 4s, 11, 15, 19. So goes up in 4s, so it's in the 4 times table, so we know it's to do with 4n. So if we write the 4 times table underneath, then how do we get from the 4 times table here to what we want? Well, if we do the 4 times table and we take away 1 each time, then that will give us the answer. So in this sequence, the rule would be 4n minus 1 in terms of an algebraic expression, because if we wanted the first, second, third, fourth, the fifth term, n would be 5. 4 times 5 is 20 minus 1 gives us 19. So 5n minus 1 for the first part. Here are the first 5 terms of a different sequence. An expression for the nth term of this sequence is given by 3n minus n squared. Well, first of all, let's just check that out. So if n is 1, we'd have 3 times 1 minus 1 times 1, which is 3 minus 1, which is 2. And let's check it out for, say, 1, 2, 3, 4. So if n is 4, 3 times 4 minus 4 times 4 is 12 minus 16, which is minus 4. So yeah, that's fine. Write down in terms of n an expression for the nth term of a sequence whose first 5 terms are these ones. Well, that's not quite as hard as it looks. If you can spot that you basically double all of these terms here, then you can be quite sneaky and say, well, it must be 3n minus n squared all multiplied by 2. So that would be okay, but a nice, neater way of writing it would be 2 lots of 3n minus n squared. In fact, some of you that are really at the top end here could see that n would factor out as well, and you could write 2n lots of 3 minus n as your answer. But I think I would do this. The reason is because, and I've said this to a lot of my students, people who mark exam papers are not always experienced teachers, so don't try and be too clever sometimes, because if it's not on their mark scheme, they might not give you the mark. So don't be too clever with your maths, just give them enough to give you the full marks. So that's what I would have said with that one. Well, this question wants you to look at integers. So an integer is a whole number. So we want whole number values, and we've got to be able to read this inequality properly. So I always get my students to read from left to right. So it means negative 5 is less than y. So if negative 5 is less than y, so I draw it in terms of a picture where you can see the size, then that would mean y has to be greater than negative 5. So if you have a number line here, and so on, then you know y has to be greater than negative 5. Now it can't be negative 5, so sometimes in examinations you have to show the possible values on a number line. So you would put a hollow dot. If it could be 5 here, then you would put a full dot, okay? But that's not what we're looking for in this situation. We're looking for y is greater than negative 5. So that could be carrying along all the way down to this number line. You'd go on forever. However, once you've read that part, then start from the middle again and read from left to right from here. And y must be less than or equal to 0. So it can be equal to 0 and less than it. So it can go all the way along here, off to negative infinity. But you've got to look at the numbers which satisfy both conditions. So you've got to think, well, I can't be negative 5, but I could be negative 4, I could be negative 3, yeah, that's fine, and this one. And then look on this one, yes, you could be on 0 here, and yes, you could be 0 here as well. So they would be the values that I would choose. So just be careful when you're reading an inequality, okay? It's really important to get it right. And do draw a diagram if it helps. So with this one here, we've got 6 lots of x minus 2 is greater than 15. So with inequality signs, the only thing you've got to be careful of is situations like this. So if I say to you, is 3 greater than 2? You say yes. And then if I asked you, if I timed both sides by x, is this still true? Maybe half of you still think yes. Well, not necessarily, because x could be negative 1. And if I said 3 is greater than 2, and then I times both sides by negative 1, negative 3 is not greater than negative 2, because if you look on a number line here, then if you put negative 3 here, and there's negative 2, negative 3 is actually less than negative 2. So be very careful with inequalities, especially when you're timesing by a number which is negative. So we should be treating this similar to an equation, but just be very careful what we do to both sides, and if we ever do this timesing by a negative thing, then just watch out. Okay, so first things first, I think I would multiply the brackets out. Not broken any rules there, so that's good. Now I'm going to add 12 to both sides. And now I'm going to divide by 6. Now 6 is a nice positive number, so it's not going to change the direction of the inequality. So we would have x is greater than 27 over 6. Now you can change this to 3 times 9 over 3 times 2 and have x is greater than 9 over 2. And so on a number line, you would just have a hollow circle going off towards infinity, and this would be 9 over 2 here on the number line. One alternative here, I just want to show you something here, is if you had 6 lots of x minus 2 is greater than 15, then you could divide both sides by 3. 3 is a nice positive number, so you won't change the inequality sign. Just in case you're wondering what I mean here, let's do an inequality. Is 9 greater than 3? Yes. So if I divide both sides by a nice positive number, does that still hold? 9 divided by 3 is 3. 3 divided by 3 is 1. And is 3 greater than 1? Yes, it is. So in this case, the inequality sign won't change. And I could have had this, then multiply out the brackets. Add 4 to both sides, and again adding 4 is not going to change the inequality. If you think you have a number, 9 is greater than 3, and if you added 4 to both sides, you'd get 13 is greater than 7. That's still true. In fact, you could still take away a number from both sides, and 5 would still be greater than minus 1. So it's only when you're timesing by a negative. I know I've gone on about that quite a lot, but I know when I've taught A-level, some students really haven't understood that concept and then get inequalities completely wrong. So for this situation, we're going to have 2x is greater than 9, so x is greater than 9 over 2. There are other ways of doing it, but there's 2 ways for you for nothing. So let's look at the next question. So a party's being planned. Again, there's a lot of words in here which is really going to, worry a lot of people. But try not to. Just try and think of what the question is asking and then go from there. Well, this question to me is about seeing 12 for the cakes. So we'd have cakes here 12 and sausage rolls here as 8. And it's giving you the cost of these. That's fine, you can look at that afterwards, but you have to have more than 60 cakes and more than 60 sausage rolls, but you want exactly the same number as cakes as sausage rolls. So it seems like the question's quite difficult, but actually if you just do the multiples of these, so you get 12, 24, 36, 48, well there's our magic 60, but we have to be more than 60. So we could go on here and so on. And then look at your sausage rolls here. 8, 16, 24, 32, 40, 48, 56, 64. So we've gone past that magic number of 60. However, we haven't got a situation where we've got the same number appearing in both columns. So if we carried on and had 72, then I hope you can see now that before I had 72, there was nothing corresponding in either of those columns. None of the numbers were the same. So although we'd gone over 60 for sausage rolls and we'd gone way past 60 here for cakes, that wasn't going to be what we needed. So as soon as we had 72 in this column here, then that matched 72 in the cakes column. So we had met both of the conditions, i.e. more than 60 in each case and exactly the same. So really that was called lowest common multiple. Okay, so that's really what we had to look at here. So we know there's got to be 72 cakes, 72 sausage rolls. Now, if there's 12 cakes in each box, so let's look at the cakes first. So 12 cakes in each box, and 6 times 12, you can just count, 1, 2, 3, 4, 5, 6 times 12 is 72. Then I'm going to have 6 boxes. So you can do that on your calculator, and I think you get 4, that's 10, that's £15. That's for the cakes. And then 8 sausage rolls in each pack, and each pack costs £1.20. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 packs. So for the sausage rolls, you have 9 lots of £1.20. 9 12s are 108, so you can do that on your calculator, so don't worry. So that's £10.80. So the least amount of money that you'd have to pay would be £15 and £10.80, which by my reckoning would be £25.80. Well, in this question, you've got a diagram that shows the positions of 3 turbines at A, B and C. And it says A is 6 kilometres due north of B, C is 4.5 due west of turbine B. Calculate the distance of A to C. Well, if this is not Pythagoras, I don't know what is. So we would have a situation where we'd want the area of here, which would be 36, and then the area here, which is 4, 5, that's 20.25. Of course, you can do this on your calculator, okay? But we know that Pythagoras' theorem stated that the 2 smaller areas always make the larger one, okay? So the 2 smaller ones added up would be 36 and 20.25. Of course, you'll probably do this on your calculator. So we get 56.25, and I just happen to remember that 75 squared is 5625, so that's got to be, I'm going to go with 7.5 kilometres. Okay, so that's Pythagoras. So if you kind of think of the diagram like that, of the squares, then if you want to find one of the shorter ones, don't make the mistake of adding. So for example, if you had a situation where you had your squares like so, and say this was 3, say this was a length of 3, then this area would be 9, and say you were given that this one was 5, so that was 25. You'd find this area not by adding 25 and 9, you would say the 2 smaller areas make the larger one, so you would do 25 minus 9 makes the one of the smaller. Okay, use your common sense there, but use a diagram. So that's that there. Now we've got to look at something which causes students a lot of difficulty, and that is bearings. So it says calculate the bearing of C from A. Well, if we look back at this diagram here, let's just draw it out. And we have C here and A is here. We know we have a north line drawn in for us here. And we want the bearing of C from A. So we've really got to start turning this way until we get to C. So bearings are always 3-figure, and they always turn clockwise. However, when you're talking about angles higher up and at degree level, A level and degree and beyond, angles turn anti-clockwise. So I'm not a particular fan of bearings really, but it's something which is on the syllabus, so we have to do it. So we turn clockwise until we get to the line where it's connecting A and C. If we had to go on the bearing of A from C, then we'd draw a north line at C, and we'll just turn on that north line clockwise until we got to the line connecting C and A. So the key word here is from, and what directly comes after that is where you need to start with your north line. Okay, so let's get back to what I was trying to do here. So give your answer to correct to the nearest degree. So there's going to be some trigonometry going on here, I'm pretty sure. So it would be nice to know what this angle here was, because this is pretty obvious. This is 180 degrees, so we can definitely say there's going to be 180 in there, but we've got to work out this angle here. So if we draw out this triangle, you'd probably do it quicker in the exam, but I'm just trying to explain it a bit here. So we've got all the information. So we've got 4.5, 6, we even have this as 7.5 here, and all we've got to do is try and work out this angle here. So you've got many ways of doing this. Some of you use SOHCAHTOA. I don't mind that too much, but as long as you understand where sines and cosines come from, and I've got videos on that with the unit circle, so I'm assuming that, well, I'm hoping you know what sines and cosines are. If not, watch the videos and I'll put a link on. If you don't and you're happy with SOHCAHTOA, then that's fine by me. So we'll have a look at this angle here. So we could say opposite over adjacent. And so we could say tan of the angle is 4.5 over 6. Or we could say a situation where it's opposite over hypotenuse. Hypotenuse always being opposite the right angle, it's always the largest. So we had opposite over hypotenuse, which would be sine. So we could say sine of theta is 4.5 over 7.5. We could always use cos, and I'll do that here. So cos will be adjacent over hypotenuse, so that would be 6 over 7.5. So once we've got that written down, all we need to do now is find what the actual angles are. So hopefully on your calculators, if we go with this one first, if we had tan theta is 4.5 divided by 6, then if we want the angle, we have to find the inverse function. And I'm not going to go into too much detail on that because it is quite complicated, but hopefully you'd know you have to do tan to the minus 1 of both sides. So your angle would be tan to the minus 1. Make sure your calculator is in degrees and not something like radians. That would be pretty disastrous. So you'd have tan to the minus 1 of 4.5 over 6. And that would give you 36.86989765 degrees. In fact, all of these would give the same answer. So we now know what the bearing is because we already had 180. So we've got 180. So we would have 9, 6, 8, 6. Now we want it to the nearest degree, it said, so we would have to 3 significant figures. We would have 217 degrees, and that would be the bearing that we would want. So the bearing of C from A would be 217 degrees. Now in this question, we've got to work out the value of something given in standard form. Now, let's look at this carefully because these aren't too bad. If you start with the powers of 10 first, so we've got 10 to the 4 times by 10 to the 3 at some point, and that would give us 10 to the 7, so that's really important. And then you can use your calculator to do 7.5 times 2.5. I will do it without, so I'll have 75 over 4, and then 4's into 75. Well, that's going to be 18.75. Now, you may think that's the correct answer, but when you give something in standard form, here's the kind of rules here. So if you were to write this number in standard form, the answer would have to be what? Well, you want to see how many powers of 10. It's in the hundreds, so it's going to have 2 powers of 10, and then you've got to say to yourself, what would I times 100 by to get there? Well, it's 1.21 times 10 to the power 2. If you had a number like 53, then you know that it's got 1 power of 10 in it because it's in the tens. I've got 5 tens and a 3. So we know I've got 10 to the power 1, but what would I have to times 10 to the power 1 by to get 53? Well, that would be 5.3. So in this case here, you're not quite done, because 18.75 is in the tens, because it has 1, 10 and 8 units, so there is another power of 10 in there. So hopefully you can understand now that standard form is not all that difficult. You've got 1.875 times 10 to the power 8. Let's just do an example here where you've got smaller numbers. So let's just say you had 0.2. Then that would not be standard form. You'd have to have a situation where you looked at how many powers of 10 it actually had. Now you're in the tenths here. Now if you look at indices, maybe you've been taught this pattern before. Let's do a few more. Oops. 10 to the minus 2 and so on. You're looking at this situation, you're looking at tenths, and you're seeing how many tenths this has. Now tenths are down here because this number here is 1,000, 100, 10, 10 to the 0 is always 1. This is a tenth. So you're knowing that it's definitely to do with tenths. So you're saying, right, okay, but what have I got at times tenths by to get 0.2? Well, the answer is 2. So it's 2 lots of a tenth. So standard form is just about looking at the place value. So we'll do one more here. So what would that be in standard form? Well, it's got 362 tenths, or it's given to the nearest tenth. So we put in 10 to the minus 1 to represent tenths, and we just say, what do you times tenths by to get 0.362? Well, you can try that on your calculator. Just do 3.62 times 1/10, and you will get exactly what you started out with here. That's called an ordinary number, as opposed to its standard form. And standard form is just basically used for really, really large numbers or really, really small numbers. That's generally what it's usage for. It just saves you writing out all those digits, I suppose. Now, let's have a look at another question. So, quadrilaterals here, they're mathematically similar. Now, what that means in maths is that one shape is an enlargement of the other. When you're using the word in the English language, you could say that one tree is similar to another tree, but that wouldn't happen in real life because the trees would have to be exact copies of each other in terms of one would have to be larger in all dimensions. So if this was 2, that would have to be 4, and I doubt if that would happen in real life where you'd have 2 trees that were looking the same but one was an exact enlargement of the other in all directions. So in maths, similar means there's some scale factor where one, the smaller one, is times by that scale factor to give the larger one. Okay, so don't get mixed up with thinking they look roughly the same. That's not what this is about. So one is an exact enlargement of the other. If the scale factor is 1, by the way, then it's congruent. That would be something different. That would mean exactly the same. So we've just got to work out the length of L to P. So the important thing is first is we'll just label this, say, T, and we want to look at what the scale factor is. So we've got DC must correspond to PN, so that should help us find out the scale factor of enlargement. So that means 6 times some scale factor of enlargement, x, is 9. And then we can find that x must be 9 divided by 6, which your calculator will probably give 1.5. I might use 3/2. It's really up to you. So that's the scale factor. I'll write 3/2 here. And all you've then got to do is work out the value of t. Well, this side here must correspond to this side here. So for it to be the same kind of similar shape as in a quadrilateral, then all we have to do is say that in the diagram 5 times something is t. Okay, now that means 5 times the scale factor that we found is t. So you can do that on your calculator. You'd get 15/2 or 7.5. Okay, so that's 7.5 centimetres. We now want to work out the length of BC. So this length here corresponds to this length here. But surely that means BC times the same scale factor will be 12. So all we have to do is multiply both sides by 2. And so 3BC would be 24, so BC would be 8. I think when you had your calculator you could just say BC is 12 divided by 1.5. It doesn't really matter, I'm just trying to show it as if you didn't have a calculator. I think sometimes calculators can make you a little bit lazy. So BC is 8 centimetres. In this question, £200 is invested for 2 years. The first year, 3.3% compound interest, which means that you just apply the interest rate to the amount of money, and then in future years you would have to then take the money you had at the end of the first year and apply the interest rate again. You wouldn't just do it as simple interest where, for example, you worked out the interest rate and just timesed it by the number of years. You'd have to do it in a compound way, and I'll show you how that is built up in this problem. So if you think of 3.3%, here's a little aside here. I want you to start thinking about that as a multiplier. So if you wanted something to go up by 50%, you would have an amount and you would times it by 1.5. Now you might think, well, that's not 50%. Well, actually it is, because if you're timesing by something by 1.5, then if you times this bracket out, you'd have the something you started with plus 50% of it. So if you times something by 1.5, what you actually do is add 50% onto the value that it started with. So if we take a number here, say 10, and I times it by 1.5, does that add 50% to it? Well, 50% of 10 is 5, so you'd hope the answer was 15. So let's have a look. If you do it like this, this will help you understand what's going on. 10 times 1 is the principal value, is what you started with, and then you'd have to add half of 10, which is 5. So by timesing something by 1.5, you actually add 50% straight on. So can you think what you'd have to times by to add 3.3% on all in one go? Well, if you wanted 3.3% added on to the original amount, you're going to have 1 point something. Well, if you did 1.3, that would actually add 30%. And if you did 1.33, that would be 33%. All of these are too much. But if you did 1.03, that would be 3%. So 1.033 would be adding 3.3%. So you'd have to times this by 1.033. This is just one way of doing this problem, by the way. There are other ways of doing it. And then for the second year, in case you can't see that, that says 1.5%. So that's how much money there'd be in the first year. And I'm not going to work that out just now. I'm not really that interested in what that is. That's just how much is in the bank account at the end of the first year. Then what you take is that whole amount, and compound means you'd have to apply another 1.5% interest to it. So what you'd have is, you'd have to times it by 1 point, or what do you think it is? 1.015. Because what that would do is, that would take all of this money here, and it would times it by not only itself to give the original amount, it would also, all in one go, add 1.5% to it as well. So your final amount would be 200 times 1.033 times 1.015, and these are called multipliers. Okay, it's a quick way of adding money together in terms of compound interest. So I'm going to work this out on my calculator now, and my calculator says 209.699. So to the nearest penny, I would say £209.70, and that would be to the nearest penny. Okay, so that would be my answer. Now, there would be other ways of doing it. So, for example, you could take the £200 and then you could find 3.3% of it. Okay, now I think that would be £6.60. And then you'd add that to the 200 and you'd get £206.60p. And then you'd have to do 1.5% of this. So you'd then have to find 1.5% of this. Well, 10% would be 20.66, and so 1% would be 2.066. So that's 1. And then 0.5% would be 1.033. So 1.5% would be 9903. And then you just add that on to this amount here. So you'd have £206.60 and 3.099. And that too would give you £209.70 to the nearest penny. So there are plenty of ways of doing it, but this is by far the quickest. And by the way, if you had an amount of money and you wanted it to lose 10%, you just times it by 0.9. Because what you're saying is, timesing something by 1 keeps the whole amount. So if you times it by 0.9, you automatically lose 10%. So it's quite useful when you've got a calculator to do percentages in this way, actually. Now let's have a look at part B. And part B is QWC, Quality of Written Communication. So it says Katie travels to work by train. The cost of her weekly train ticket increases by 12.5% to £225. Katie's weekly pay increases by 5% to £535.50. Now you've got to be really careful here because this is quite a difficult question. You've got to look at the increase in amount. So you know, for example, that when you're looking at the tickets here, the tickets were increased by 12.5%, and that's how much they were, 225. It says 2. And then for the pay, well, the pay was increased by 5% to get this situation, because it was increased by 5% to this amount. So what you'd have to do is find what the original amounts were. So for the first situation, you would say the original amount was 225 divided by 1.125. So let's look at that. 225 divided by 1.125, and you get 200. And then in this situation, for the pay, you'd have £535.50 divided by 1.05. So that would be 510. So what you're going to have to say to yourself is the end point to the start point for the tickets is a £25 increase, and for the pay you're on 535 and you end up with 510 as a starting point. The difference between that is £25.50. So basically the difference between the tickets and the pay is only a 50p difference, which unfortunately was not going to give Katie very much leeway in actually putting that 50p towards anything. Maybe she could buy herself her newspaper once a week or something to read on the train. Anyway, so that's the difference in the increases, and we've compared them, and that's what we've come up with. So let's look at the next question. It says, here is a cuboid. Oid means like. So, for example, android, like a human. Ovoid, like an oval, and so on. So cuboid, so it's like a cube, but it's slightly longer in one of the directions, or two of the directions, and so it's given. P is a vertex. Well, vertices is the plural, and these are like the corners. So P is the vertex of the cuboid, and it's given here. T divides the line OP in the ratio 1 to 2. Find the coordinates of T. Well, this is again quite a complicated question, so let's enlarge it a little bit. So if we draw a line from O to P, like so, let's have a look, let's try again. There we go. Then we want to try and look at how we get to that line to start with. So how we get from the origin here to P, but on the X, we've got to go 1, 2, 3, 4, 5, 6 units on the X. So we're then on this face here of the cuboid. Then we'd have to, on the Y, go up how much? Well, 1, we'd have to go 2, 3, 4, we'd have to go all the way to the top here, okay? And then we've got to come inwards this much in this direction. So it's got to be parallel to this axis, which is parallel to the Z axis. So we've got to go, well, it's counting positively here, so we've got to go this distance in here, which is the same as this one, which is the same as this one. So 643 is the coordinate of P. Now in 3 dimensions that's quite difficult to see, but all you've got to know is you've got to move in the X first. I'll do that in a different colour. So you move in the X first, then the Y, and then the Z, and just be careful of the actual values, because sometimes they try and trick you where they have the positives coming this way for Z, but in this case this was +3, so we knew which direction we were going. It says that T divides the line OP in the ratio of 1 to 2, so 1 part to 2 parts. So that's the next thing to look at. Well, when you've got this ratio, how many parts do you have? You have 3 parts. So if we were to split the coordinate down here into its parts, So if we divided each of them by 3, because there'd be 3 parts, we'd have 2, 4/3 and 1. So what I've done there is divided this by 3, this by 3 and this by 3. So in effect we have a coordinate somewhere and we've got to work out where that is. So if you think about the question, it wants it divided in the ratio 1 to 2. Well, if we cut it into its 3 parts, like so, we've got to do it in the ratio of 1 part to 2 parts. So t will be here. So if you can see this, this is going to be 1/3 of what OP was going to be. And so that was actually the coordinate that we wanted. So OT as a vector would be 2, 4/3, 1. But if we want t as a coordinate, it's just going to be 2, 4/3, 1. That's very similar to the first question where we looked at the average of the points. I think that was question 1 on this paper. So that's the coordinates of t. For this question, 25 students in Class A did a science exam, 30 students in Class B did the same science exam. The mean mark for the 25 students in Class A is 67.8. The mean mark for all the 55 students is 72. Work out the mean mark for the students in Class B. So for this question, I would look carefully at this information because at the end of the day, you want the mean mark for all the students in Class B. Well, I would look at the situation for everyone first. So there's definitely 55 students altogether, and we have all of the A's here, and there's 25 of those, and then we have all the B's here, and there's 30 of those. Well, to get the mean, don't we have to add up A1 plus A2 all the way up to the 25th student? So we have to add up all of their marks, and then we have to add up all of the B students all the way up to the 30th. Add all those marks together and then divide by 55, and it thankfully tells us that the answer is 72. So let's just write this out again. Well, this is nice for the calculator because you've really got to try and focus on this set of information here because you really want to be looking at Class B. So what we can say is, let's just minimize this a little, we can work out what the top row is. So we know that A1 plus A2 plus all the way down to B30, this is this whole top line here, is going to be 55 times 72, which we can work out. So 55 times 72. So we know that A1 plus A2 plus all the B students, their total marks is 3,960. But the nice thing is it tells you that the mean mark for the students in Class A is 67.8. So it means that when you took all of the A students, those 25, and divided by 25, you actually got 67.8. So that means that A1 plus all the way up to A25 must be 25 times 67.8. And that's 25 times 67.8, and that is 1,695. So let's compare what we've got right now. We know what all of this is here. There we go. We knew all of this here. and we wanted to find the mean mark for the students in class B. So the students in class B we can now find, because in this equation here we have all of this, which is 1,695, plus the B students' marks, which are left, okay, and that's equal to 3,960. So that means all the students in class B, all of their marks must add up to 3960 minus 1695. So we're going to have 2,265. And then we've got the answer really, because we can now work out the mean mark for the students. So that's all their marks divided by how many there were, which in this class was 30, and we can just put that in our calculator. So we get 2265 divided by 30, which is 75.5 marks. So for this question, I think it's good just to write out what the whole of the students would be. So you just kind of think, well, I know that I had 55 students, I know the mean for all of them was 72, and then you can just imagine listing all the students, all the A's and all the B's and so on, adding them all together, and then trying to find out the unknowns. So in this situation, we worked out from here, this was where we started. This then gave us this equation here, and then we used the information given here to find another equation, and then that enabled us to eventually work out the sum of the B students, which was one thing that we didn't know, but we did know there were 30 students, and that enabled us to find the mean. So give these questions a try. They're quite difficult. I've seen them quite a few times over the last 5-10 years. But just try and write out some kind of equation, or at least list things for students or marks, and try and show all your stages of working. You will get there in the end. Just try and use some common sense, but try not to worry. All the question is doing is it is giving you just enough information to work out what you need. So in this situation now, we've got to multiply these two brackets. I would use a grid. So we've got y minus 2 times y minus 5. So we've got y squared. This would be minus 2 times minus 5 here. So that's a positive. And then we've got minus 2y and then minus 5y. So what we'd end up with is y squared minus 7y plus 10. I think some mistakes are people not quite sure how to multiply these out. I think some people do this method here, which is fine, but as long as you understand that the two minuses in conjunction with each other when multiplied give a plus, and that you're not doing 2 and 5, which is 7, you're not doing that. You've got to multiply. So that's the first one. So I'll write that here. Then it says prove algebraically. Don't forget QWC. Show your workings out properly. You've got to show that it's an even number. Now for something to be an even number, it's got to be 2 times something. And just call that something k. So we've just got to basically work all this out and hope that it's 2 times something. Okay, that's it. So we'll try and do it all in one go if we can. Now there's numerous ways of doing this. If your algebra is really good, you can see that 2n plus 1 is a factor, and then you'd have 2n plus 1 minus 1 here, which would give you 2n plus 1 lots of 2n, which is the same as 2 lots of 2n plus 1 times n, which is 2 lots of something. That something being 2n plus 1 lots of n. So that's one way. If that's not what you like, then you can say 2n plus 1 squared minus 2n plus 1. You can square this bracket out and you'd get 4n squared plus 4n plus 1 minus 2n minus 1. And that would give you 4n squared plus 2n, and then you can factorise that out. You can take out a 2, which would give you 2n squared plus n, and then you could take out an n as well, and that would give you 2n plus 1, which is exactly what we had here. So what you really want to be looking at is it 2 times something? Yes, it is. So therefore even. So that's a really good way of doing it. You just want to show that it's 2 times something. Even if you got an answer of 4 lots of something, then you just say that's 2 lots of something. As long as you've got the 2 in front, then you're okay, because any multiple of 2 has got to be an even number. Okay? So for this question, then you need to look at it very carefully and realise again that it's QWC, quality of written communication, and you've got to test whether Shabin is correct in what they're saying. Now, let's have a look. We've got the probability that the coin will land on heads is 0.6, so it's not a fair coin, it's biased, that's fine. Now, if we had a probability tree here, so we had heads and tails, that's the first, and then heads and tails again, that would be the second, and then heads and tails again, just showing all the different trials that you can have. We want a situation where we've got tails followed by tails followed by tails. So the probability of 3 tails would be, well, if it's heads 0.6, then tails has got to be 0.4 each time. So it's going to be 0.4 times 0.4 times 0.4. And I've got a little video explaining why it's times, and I'll put a link up here for you. So the probability of tails 3 in succession will be 0.4 cubed. Well, 4 cubed is 64, but we want 64 divided by 10 3 times, because if we had 4/10 times 4/10 times 4/10, which is what we've got 64 divided by 1,000, and that would be 0.064. And of course you've got a calculator, so that's not going to be any big deal. So she says the probability that the coin will land on tails 3 times is less than 0.1. Well, if we compare this with 0.1, this has a tenth, this has none, so this is the winner, therefore this is less. So she says the probability that the coin will land on tails 3 times is less than 1. Is Shabin correct? Yes, she is. So just write that clearly. Okay, let's have a look. Well, to me, explain what is meant by a stratified sample. I would say that it's a sample which is in the same proportion to a given population. So you can say population characteristic. Now, you haven't got to use these really big words. What you're trying to say is that when you take a sample and it's stratified, it's got to somehow be in the same proportion or represent the larger sample from which it was taken. What you don't want to do is, in this situation, is say, for example, when you've got the whole situation coming here, if you were trying to do a small survey of all of those people and you were just to ask, I don't know, the first 10 under 21s and think that that's a stratified sample, well, of course it isn't, because you're not taking it proportionally from each of these parts. Okay, so we've got to keep our eye on the word proportion. That's the main thing. So let's have a look at how we can do that. Mrs. Parrish carries out a survey of these people. She uses a sample size of 50 people stratified by age group. So here's what you've got to do. I would say in this situation, add these numbers together. So we're going to get 7, that's 9, and then 16, 17, 18, 19, and then 3, 4. We've got 599 students, which is fine. And then we want to take 50 people stratified by age group, work out the number of people aged 60 years and over. Well, all you've got to say is, out of the 599, 72 of them were under 21, 90 out of the 599 were aged between 21 and 40, and so on. That's the first thing to say. So what we want to do is, if we wanted to find a stratified sample of 50, then we would just do 72 599ths of 50, and that would give us a number, 90 599ths of 50, and so on. And let's see what those are. And then what I'm going to do is, this tells you how many people you would take in the same proportion, and I would just round these to the nearest whole number. So in this case I would say 6 for this one. I would say 7 or 8, but go with 8. For this one I'd go with 10, and this one I'd go with 26. Now if we add those up, 26 and 10 is 36, and 14 gives us the 50. So now look at here, and I would say people age over 60 years of age in the sample, 26 would do this. It would be a sample which is in the same proportion to a given population, and the given population was the 599 that I started with. Okay, so hope that explains that a little better for you. So let's move on now. It says P is inversely proportional to T. When T is 4, P is 12. Find the value of P when T is 6. So inverse and direct proportion. So if P is inversely proportional to T, that's how we'd write to start with. If it was directly proportional, we'd have P is directly proportional to T. If P was directly proportional to the square of T, if P was inversely proportional to the square of T, and so on. But we have P is inversely proportional to T only. So the kind of situation we're looking at here is a graph like so. So if we have the t-axis and the p-axis, it's basically saying as one goes up here, as t goes up, p comes down in value. Okay, so that's this one here. So what that means is, if p is inversely proportional to t, that means p could be equal to k over t. Now this is what worries a lot of students. All you're saying is that this k can take on different values. So it could take on a value like so, it could be this graph, it could be this one, and so on. It's none of the negative ones here, because some of you might understand y as 1 over x can take on values that are negative. In this situation we're just going positive t and positive p. Now this k is actually a scale factor, so depending on what k is, it will just stretch this hyperbolic function, which is what this basically is, outwards or inwards. So if you had k as a very high number, say 100, it might start looking something more like this, whereas if k was like 0.2 or something, you might get something closer to the origin like so. So we know p is equal to k over t for some value k, but we should be given enough information to now find that value of k. So it said that t is 4 and p is 12, so we put that in here. And that means that k is 48, so p is 48 over t. So that is the actual graph that we want. Okay, so what's that basically told you is, and I'll try and use a different colour on here, it's trying to say, well, this is the actual one that you want. Then it says, find the value of p when t is 6. Well, when t is 6, we just put this into here. So we'd have p is 48 divided by 6, and you've got a calculator, and 8 6s are 48, so p is going to be 8. Well, for this question, you've probably got some things on the formula sheet. So what you may have is the formula for a sphere. You can look back and see for yourself. And the volume of a sphere, let's have a look. Volume of a sphere is 4/3 pi r cubed. The volume of a cone is, well, the volume of a cylinder, funnily enough, if you take a cylinder and you put a cone inside it of the same height, there you go, then basically 3 of those cones melted down would fill that entire blue cylinder up. It's the Archimedean principle, so it's the same if you've got a cuboid like so. If I was to place a pyramid inside it of the same height, then I could melt 3 of those pyramids down, and that would fill the entire volume of the cuboid. So I know that the volume of a cylinder is pi r squared h. So I know the volume of a cone must be 1/3 of that. So that's of some interest. It says the radius of the hemisphere, so that's half a sphere, is 4 centimetres. The radius of the base of the cone is 4 centimetres. It just wants the volume of the solid, so you just have to get on with it and see what you get. So the volume of the cone on top is going to be 1/3 of what the cylinder would have been. So imagine there was a cylinder drawn around here. Now that would be 1/3 of pi times the radius squared, which in this case is 4 times the height, which, well, this is the interesting thing now, because this is a bit of a trick, because this is all 14 down here, so you might think it's 14 here. Well, if you just swing this radius down here, and swinging that radius is a very, very common thing I've seen over the last 20 years of teaching. Sometimes in a situation, if you just swing that radius round a little, you can find the solution to the question. Trust me, that's always a good thing to do. So you know that actually this is 10 from here to here. So the height of the cylinder, not to be confused with the cone, the slant height of the cone would be L. Okay, but we want the perpendicular height here. That's what this formula is telling us. So we've got 1/3 of pi times the radius squared times the height, which is 10. And then we can work that out. So we've got 16. You can put it all into your calculator, obviously. So 16 tens are 160. So I'm going to leave it as 160 pi over 3. And that is going to be centimetre cubes. And then I want the volume of the hemisphere. Well, the volume of a sphere is going to be 4/3 pi r cubed, but I want the hemisphere, so I've got to halve it. So I'll have 4/6 of pi r cubed, which is the same as 2/3 of pi r cubed. Of course, you might be cutting corners and putting stuff on the calculator. That's absolutely fine. So let's see what this would be if I put the numbers in. It'll be 2/3 of pi times the radius. Well, the radius of the sphere is 4, so it'll be 64. So I will get 128 pi over 3. So the volume altogether would be 160 pi over 3 plus 128 pi over 3, which works out to be 288 pi over 3. But I've noticed one thing here, and that is 288. If you add the digits up, you get 18, so 3 must go into this. So 3 times, well, what is it? 7, 8, 9 3s are 27, and that's 1 left over, that's 6. So that is 6. So I've got 3 times 96 over 3, lots of pi, which is just 96 pi. So that would be my answer in terms of pi, and then I'll just put that into my calculator, and I'd have 96 times pi. And that would give me 301.5928 and so on, but I want it to 3 significant figures, so to the nearest unit. This is the decider here, so it would be 302 centimetres cubed. And that would be my answer. With this question, I just want to go over a few details about what this actually is and what this is. So we'll start with the difficult one. Some of you may know that the formula for a circle centred at the origin is x squared plus y squared is r squared. So in this case, if you compare r squared with 36, you can see that r would have to be 6. So let's draw this here. Okay, so we can draw the circle now, and there we have it. So that would be the first equation, that's what it would look like. Then if we looked at x equals 2y plus 6, we would then see that if we want to get it in the form y equals mx plus c, we'd have x minus 6 is 2y, and then divide everything by 2. That would give us y equals a half x minus 3. So the gradient is a half and its intercept is at minus 3. So if its intercept is at minus 3 and its gradient is a half, just think for every one I go along, I go up by a half. So if I go along 2, I'd go up 1. So along 2, up 1, and then I can draw my straight line through here. So that's just a rough sketch of what we've got here. Now this may come in useful for later on. You may not have time in the exam to do it, but if you have, then I thoroughly suggest that you do it. So let's have a look at the question, and now let's do some algebra and see what the algebra tells us. So x squared plus y squared is 36, and x equals 2y plus 6. Well, this is telling us that x is 2y plus 6, so let's substitute it in here. And we'd have 2y plus 6 all squared plus y squared is 36. Let's do a little grid down here. There's no shame in doing that at all. So we'd have 4y squared, 12y, 12y, and then 36. And then if we add these up, we'd get 4y squared plus 24y plus 36 plus y squared is 36. 36 cancels from both sides. 4y squared plus y squared is 5y squared plus 24y equals 0. And that's where a lot of people will start to worry, but don't, just soldier on. And if you took a y out here, you'd have 5y plus 24 equals 0. And what this means is that this value times this value is 0. So this could be naught, or this could be naught. And then again, this would give y is minus 24/5. So, how does that help us? Well, let's have a look at the diagram. If y is naught, where are we when y is naught? So we're down here. So when y is naught, there is a value here, and it looks like 6 on my diagram, but let's just have a look and see if it is. So y equals naught. Let's put that into the straight line, and we'd have x equals 2 lots of naught plus 6. Well, x would be 6, so that's really good. So our diagram even told us that. Okay, so there's one situation. Y is naught, x is 6, and I would call that I1, intercept between the circle and the line. I1 is 6 naught. If you just want to write 6 naught in the exam, that's absolutely fine. And then the other value is a little bit more difficult, but minus 24 over 5, do that on your calculator, minus 48 over 10 would get roughly minus 4.8. And if we look on the diagram, minus 4.8 downwards, 1, 2, 3, 4 and a bit, 4.8, and we read along, then that's pretty good going. That does kind of coincide with what we said. So that's one coordinate we've got here. We now need to find the other one. So we've got y is minus 24/5. So we just plug this into this equation. So we've got 2 lots of, and I'm going to just put in the decimal for now, which is probably what you'd do on the calculator anyway. And we'd get x is minus 3.6. Okay, that's a 6 there. So let's just see if that coincides. 1, 2, 3.6. Okay, it's slightly off, but that would be the answer. So our second solution would be x is negative 3.6, y is negative 4.8. So hopefully that's made a little bit more sense to you, and the diagram has helped a little bit. So for this question, we've got to work out the area of the parallelogram and give your answer to 3 significant figures. So, not an easy question to be honest with you, but you know with a parallelogram that this would be 11 centimetres at least, so you can put that in. So I think what I'd be looking for is, I would want to be using the area of a triangle, which is probably on the formula sheet, a half AB sine C. And yes, it is on the formula sheet, so you can scroll back and have a look at that. Well, I think the fact that I labelled this 11 here kind of gives a little clue, which I didn't quite see at the start, and that is if you have a parallelogram and you split it down its diagonal, you've only got to find the area of one of these and double it. So that's a big relief. So in this situation now, I'm pretty much going to go for it. So this is going to be theta here, and I'm going to call this angle beta here. So using the sine rule, I want to find an angle, so I'm going to have sine theta over an unknown, I'll call that q, is equal to sine beta over 9, that's good, is equal to sine 100 over 11. And the formula is on the front of the formula sheet. And if you want to find a length, then you can just turn all these upside down and do the inverses of them. Okay, so I'll put some links into the sine rule as well. What we want to do is, as fast as possible, find theta. So I'm going to use these two here because I can then find beta. I know that the angles in a triangle add up to 180, and then I can find theta and then just put it into the formula, times it all by 2, and then I'm done. So let's have a look. If sine beta is then 9 sine 100 over 11 because I times both sides by 9 to get rid of this denominator here. And then I'm just going to find beta by doing sine to the minus 1 of all of this. So I should put that in my calculator. And I get 53.6829239. And I would always write that out in the paper to its fullest. And then I then know that theta has to be a situation where I already know in this triangle here that 100 is taken, so theta and beta have to be 80 between them added up. So I know that if I've got beta, then theta is going to be 80 minus this number here. And so theta is going to be 26.31707.691. So what that would mean then is that the area of one of the triangles would be a half times, well, think about it, you've got the two arms here and they're made by this angle here, so you've got a half times the two arms that make the triangle times the sine of the angle, that's 26.317 and so on, and you'd put that in your calculator. Now what you'd get is, for the area of the triangle, you'd have 21.94524919, but you want the area of all of it, so you would have to double that. So the area of the parallelogram would be double that, and you'd get 43.89049 and so on, but you want it to three significant figures, so my final answer would be 43.9 centimetre squares to 3 SF. So quite a challenging paper, but hopefully the ways that I've shown you how to do these questions has helped. I'll put some links as we go along and you can look at other videos. So please subscribe to the channel, and good luck with your revision.